Okay, having a wee look at this integration one. To make this question a wee bit easier, I'd be inclined just to work out one of these areas. So you're finding the area from 0 to pi of sine x dx. Now where did sine x come from? Remember cos goes to minus sine. So you have to have a minus in front to balance it outside. So that's minus, when you integrate that back to cos, that will be minus outside, the integral still holds. So you've got minus cos pi minus cos 0. Now, cos pi works out to be minus 1. So it's minus 1. Take away 1. So you've minus 2, which is 2. But you've got 4 areas. So the total area is 2 times 4, 8 units squared. Okay, question 8b from the same paper. Now if you scroll down to find it. Okay, right. Do I have the derivative of the bottom and the top? No, I don't. What I do notice about the bottom there is I can factorise out of 3. So I just see that there, so I'm going to do that first of all. Also from the bottom, I'm also thinking of the formula. Cos squared plus sine squared equals 1. So cos squared is the same as 1 minus sine squared. So I'm going to write that as cos squared 2x. Now, I still can't integrate that at the minute. So I'm trying to think of what is cos squared. Well, 1 over cos squared is the same as sec squared. And from my differentiation, tan goes to sec squared. So I can integrate that back to tan. Derivative is a 2, balance outside. So I've got 2/3 outside the bracket. That will go back to tan 2x. And then put your limits in. Pi over 3, pi over 6. So I have got 2/3 tan 2 pi over 3. Take away tan 2 pi over 6, which is pi over 3. So just in your calculators, so if you go tan 2 pi divided by 3, the first one is minus root 3, and then tan pi over 3 on your calculators is minus root 3. So we have 2 minus root 3's, so I have got 2 over 3 times minus 2 root 3, so it's minus 4 root 3 over 3, which is what the question was asking me for. Okay, we're now going to turn to the C4 paper from this year, and we're going to have a look at question 1. Do you have the derivative of the bottom and the top? No. So you're going to use your partial fractions. So A over the first factor and B over the second factor. Then do the tops. So this fraction needs an extra 2 minus x, and this fraction needs an extra 0. Put x to be 2 to get rid of this bracket. So you have 6 equals 2b. So b is 3. And put x equals 0 to get rid of the last term. So you've got 4 equals 2a. So a equals 2. So I'm going to rewrite this integral using my a's and b's. So a is 2 over x plus b, which is 3 over 2 minus x. Now I like to split that up. So bring the 2 outside. Bring the 3 outside and check, do you have the derivative on top? Yes. So it integrates back to log. Do you have the derivative on top? No. It needs to be a minus. So put a minus on top and a minus outside. So it's minus 3 log the bottom line plus c. Now we need to go down to question 7 from that year. You're looking for the volume of this. So the volume is pi y squared. So I'm just going to square this out. Dx. So it's pi, square the first, square the last, so it's sine squared 2x, double the product. So sine is a plus the number 1 times 2, and then sine 2x. Now, trying to think here of how to integrate each of these bits and pieces. So I'll just leave that pi sitting outside, just put a big bracket around the whole thing, 1 dx. Sine squared is not on my list of things that differentiates to give sine squared. Nothing does. So I'm going to try and think of where else does sine squared come up. Well, you could use cos squared plus sine squared equals 1, but that's no use because cos squared is not on my list of trig differentials. So where else does sine squared come up? If you think back to the cos 2 theta formula, you've got sine squared in there. And cos is on my trig differential, so I could work with that. So I'm going to take this and I'm going to rearrange this. So I've got 2 sine squared equals 1 minus cos 2 theta. So sine squared theta is the same as a half minus a half cos 2 theta. In my case, I have got 2x. So it's a half minus a half cos 2 times my 2x is 4x. So I'm going to write my sine squared like this, because that has got rid of the actual squared bit, which makes it a lot easier to integrate. So it's 2 sine 2x dx. Now this is very tricky, this question. So it's pi, the integral of 1 dx, plus the integral of a half dx, minus a half the integral, I'm just splitting this up, 4x dx, plus 2 sine 2x dx. I can integrate everything here. So integrating that, you get x. Integrating a half, you get x over 2. Now where does cos come from? Sine goes to cos, so no sines to worry about, but I must have the derivative in front, so balance it outside. So that is an 1/8 sine 4x. Now where does sine come from? Cos goes to a minus sign, so you've got to balance it. Derivative is a 2, balance it outside. So you've got minus 2 times a half is 1, and this will go back to cos 2x. Now I could tidy that up, because I've got 1.5x minus an 1/8 sine, that's 4x, minus cos 2x, and I have got integral values to put in, 3 pi over 4 and 0. So putting in 3 pi over 4, I get 9 pi over 8 minus an 1/8. Putting in 3 pi over 4, I get sine 3 pi. You can work that out. So sine 3 pi, that works out to be 0. So I'm just doing both as I go along here. So that's 0. Minus cos, putting in 3 pi, so I get 6 pi over 2 over 4, which is 3 pi over 2. So just working that out is 0. That's the first bracket worked out. Take away, putting 0 in. 0 minus sine 0 is 0 and cos 0 is 1. So it's minus 1. So I am left with pi, 9 pi over 8 plus 1.